What's up, party people? First of all, if you're watching this video, do me a favor. Like, share, and subscribe. I know it's bright and early this morning. This is probably the earliest I've ever gone live. Um, and because I'm having a wonderful morning and I wanted to get some things accomplished, so I'm trying something new. So I'm going to, this video is about Unit 6, Lesson 8. And we're gonna get right into it because I gotta hurry up. I'm gonna rush these things. I gotta be to work in a little bit, y'all. So this is before work. So, in this particular activity or this particular lesson, you want to just look at these two tables first of all, and notice and wonder. You know, one of the things that you may realize is that in table A, the numbers are start out with whole numbers and then they turn into fractions, but those fractions are actually getting larger and larger. Table B, the numbers start out with 1600 and then they get smaller and smaller. Okay. So I want you to imagine this scenario that a person has $100 and they spend 1/4 of it. How much do they have left? Well, $100 is 100 cents. Um, and so, I'm sorry, not 100 cents. I'm tripping. That's a dollar. But $100, 1/4 of it is $25. And so they would have $75 left. All right. And so here's 4 different ways that we could represent that amount that they would have left. Okay. So number one, we have $100, and then you have 1/4 times 100. So according to order of operations, this would be 100 minus 25, okay, which equals 75, because you would have to multiply the 1/4 times 100 first, according to order of operations. Here we have 100, and then 1 minus 1/4 is the same thing as 4/4 minus 3/4. I'm sorry, minus 1/4, which is equal to 3/4. Okay, so that gives you 100 times 3/4, which is 75. All right. And then one same thing, as you can see there, step 3. And these are actually different versions of the same thing in a sense. So here we got 100 times 3/4, which is 75. Or you have 3/4 times 100, which is 75. All right. So I want to get to the main thing of this lesson. Uh-oh, I didn't mean to stop sharing. I want to get to the main part of this lesson, which is 2 different scenarios, one about exponential growth and one about exponential decay. All right, so it says a person makes $1,800 per month. About 1/3 of that is spent on rent. What 2 numbers can you multiply to find out how much she has after she's paying her rent? So you basically have, okay, so it says what 2 numbers can you multiply to find out how much she has after paying rent? So you have 1/3 of that amount goes to rent. So 1,800 minus 1/3 of 1,800. Okay. So you basically can multiply 2/3 times 1,800. Okay. Well, why is that? Well, because this is 1/2 of the 1,800. And if I take away 1/3 of the 1,800, you have 2/3 of the 1,800. Write an expression that only uses multiplication and that is equivalent to x reduced by 1/8 of x. Okay. So if I have x minus 1/8 of x, then I have 8/8 of x minus 1/8 of x. So that is going to equal 7/8 of x. Okay. So there we go. X reduced by 1/8 of x. And notice only uses multiplication. Okay. So that would be this right here. Cool. All right. Let's go to the next activity. All right. So notice every year car is reduced. Every year after a new car is purchased, it loses 1/3 of its value. let's say the new car costs $18,000. All right, we're gonna go on. It says a buyer worries that the car will be worth nothing in 3 years due to depreciation. Do you agree? Explain your reasoning. I would say no, simply because it's losing 1/3 of the value, and then whatever the remaining value is, it loses 1/3 of that, and 1/3 of that, and 1/3 of that. Okay, so the key that we want to look at in this case right here, let me open up my workbook so I can write these numbers down, is that you want to actually be in position for something like this. You want to take these numbers and you want to write down the correct numbers. So write an expression to calculate the value of the car in dollars. Okay, so we have 18,000, and then we're going to multiply that by 2/3 to the 1 power. Okay, and so it loses 1/3 of its value every year, right? So that's 2/3 remaining. So the multiplier is going to be 2/3 because it's losing that 1/3. And in this case, it's going to give you 12,000. And then here we have 18,000 times 2/3 times 2/3 again. Or we could write that to the second power, which gives us 8,000. Here we have 18,000 times, I'm going to write it in exponent form this time, to the third power, which gives us 5,333 and 33 cents. And then here we have 18,000 times 2/3 to the sixth power. Be careful right there. And so that would give us $1,580.25. Okay. Now, here we're figuring out after t years. So it's 2/3 to the t power. Okay. So notice it's still exponential, but the key thing you want to remember is it loses 1/3 of its value. So it's multiplied by 2/3 of the value. So that's what's remaining after the 1/3 is gone. All right. Next slide. Write an equation relating the value of the car V to the number of years T. So if we write this in function notation, V of T is going to be equal to 18,000 times 2/3 to the T power. All right, so here, use your equation to find V when T is equal to 0. So V of 0 is equal to 18,000 times 2/3 to the 0 power. Remember, any number to the 0 power equals 1. So this is basically like saying 18,000 times 1. All right. And so this is basically V of 0 is equal to 18,000. So this is basically the purchase price. Okay. So this is the purchase price, or the initial value, if you want to say that. So initial value. Okay. That's that. And let's go to the next one. It says the different car loses value at a different rate. The value of this car in dollars D after t years can be represented by the equation D equals 10,000 and times 4/5 to the t power. Explain what the number 10,000 means. So 10,000 mean is the price of the car. 10,000 is the price of the car, the initial price of the car, and 4/5 is the amount remaining. You can say multiplier. Let's say like this. Let's say like this. So this is the multiplier, right? Or it's the amount remaining after depreciation. Okay, after depreciation. All right. Very, very important here. Okay, so that's that. And I think I am going to, I know I got one more activity to do on this. I think I'm going to wrap this video up because I need to go ahead and get up out of here. Let's see. Let me see real quick. Let me see real quick. Let me see what I got. I didn't want to do that one. Oh yeah, let's do this one. Insulin in the body. Let's go the other way. I think I can do it real quick. All right. So this one, it says a patient who is diabetic receives 100 micrograms of insulin. The graph shows the amount of insulin micrograms remaining in the bloodstream over time. All right. So notice it says scientists have found that the amount of insulin in the body changes exponentially. How can you check to see if the graph supports the scientist's claim? Remember, exponential functions have a common factor. So what we could do is we can look at to see if the Y values have a common factor. Okay, so how much insulin broke down in the first minute? So in the first minute, we went from 100 micrograms to 90 micrograms. So 90 out of 100 is equal to 9/10, right? So let's do it like this. 100 to 90. So 10 micrograms. Okay, so 10 micrograms broke down in the first minute. Okay, what fraction of the original insulin is that? Well, 90 out of 100 is equal to 9/10. So that's the fraction. All right. Let's go to the next one. How much insulin broke down in the second minute, right? So in the second minute, we went from 90 to 81, which equals 9 micrograms. And it says what fraction is that amount of the 1 minute earlier? So 81 out of 90 is equal to 9/10. So that what fraction of the insulin remains in the bloodstream for each minute that passes? 9/10. Well, how do we explain our reasoning? Because it goes from 100 to 90. And 90 is 9/10 of 100. And then it goes from 90 to 81. 81 is 9/10 of 90. Okay, so that's that. Now, so basically, if we have 9/10 remaining, we can take each of these numbers and multiply them by 9/10. And if we do that, this will give us 65.61, and then this will give us 59.05. How would you describe how to find the micrograms of insulin remain in the bloodstream after 10 minutes? We would start out with our initial value of 100 times 9/10 to the 10th power, and that will give us that answer. Okay. So that's that. Hopefully this video has been helpful. Like, share, and subscribe for me and for you. And thank you for watching. Remember, I got the solution to your math problems. Deuces, y'all have a phenomenal day today.